So at the end of the last video, we mentioned that this limit that we've been working with so far has actually been very, very useful. It's allowed us to find slopes of tangent lines, instantaneous velocities, and it's going to be something that we're going to continue to use throughout this semester. And typically when something gets used very often, we tend to come up with like a way to talk about it. So we don't keep having to say that big, scary limit thing. We give it a name. So here's our definition, and it's a very crucial one for us. We are going to call this limit the derivative of a function f at a number a. Notice that we're working with a function f, and we are working at the point of a. So we call the whole thing the derivative. That's the name that we're giving it. So when you hear that word derivative, you have to think to yourself, slope of a tangent line. That's the first thing that should pop into your head. You should have that instant translation. Hear the word derivative, you go, oh, that's slope of a tangent line. It's the slope of a tangent line on the function f at the value of a. Now we're also going to come up with some shorthand notation to represent it because it's going to be kind of annoying to always write out this big scary limit thing every single time. So we're going to use this set of notation here to represent that we're working with the function f at the point a, and this little tick mark up here is going to represent derivative. Okay? Now we've seen that this limit is one way that we can express the derivative, but if you look back in the notes, we've also seen that we could have expressed it in this form. And so we'll often use the first form. This will kind of be our preferred form, but every so often we will come back and use the second. So take a look at just how this notation actually functions here. Take a look at example 7. Suppose that s of t was equal to 1 minus 5t plus 15t squared. Well, if I recognize this as the same function that we had back in example 6 and in example 5, and then I recognize that example number 7 is just asking me, find s tick mark 2, or what we commonly will say is s prime 2, that really just means find the derivative. And remember, when you hear the word derivative, you know that means find the slope of the tangent line, or find the instantaneous velocity. So what's crazy here, and what's amazing, is that when I say find s prime of 2, we know that that means find the limit as h goes to 0 of s of 2 plus h minus s of 2 over h. And actually, we already computed that. We know that that was actually just 55 miles per hour. And so we don't have to worry about any changes or anything like that. No recalculations need to be done. We can just rely on the facts that we've had before. So the purpose in this video right now, what you really need to take away is that we have this new word and symbol. I'll write down here just as one final recap for us is that this is typically read f prime of a. That's how we read that statement, but it means the derivative of our function, or the slope of the tangent line of our function at that point.